Here are some representative formulas and concepts frequently used in electricity. 1. Ohm's law. It is a fundamental law that describes the relationship between current, I, voltage, V, and resistance, R, in an electrical circuit. It can be expressed as V equals IR. 2. Resistance. Resistance represents the obstruction of current flow in an electrical circuit. It is defined as the ratio of voltage to current and can be expressed as R equals V, I. 3. Impedance. Impedance is a physical quantity that represents the correlation between voltage and current in an AC electrical circuit. Electrical impedance is the ratio of voltage to current and can be expressed as Z equals V. I. Impedance can also be represented as a complex number, considering both resistance and reactance, inductance and capacitance. 4. Active power. Active power represents the actual useful power utilized in an electrical circuit. It is the product of voltage and current and can be expressed as P equals VIcos, theta, where cos, theta, represents the cosine of the phase angle difference between the voltages. 5. Complex number. In electrical circuits, complex numbers are used to represent impedance and describe the magnitude and phase difference between current and voltage. Complex numbers consist of a real part and an imaginary part, where the imaginary part is denoted by I. The magnitude and angle of the complex number have physical interpretations. These formulas and concepts play significant roles in electrical engineering and are fundamental for understanding and analyzing electrical circuits and systems. In complex numbers, the imaginary part represents one of the components along with the real part. The imaginary part is denoted by I, which is the square root of -1 and forms a complex number. In electrical engineering, complex numbers are used to represent the magnitude and phase difference between voltage and current. The real part of a complex number represents the magnitude of voltage and current, while the imaginary part represents the phase difference between voltage and current. Therefore, the imaginary part does not indicate the current flowing in the opposite direction but rather represents the phase difference between voltage and current. For example, in an AC electrical circuit, the relationship between voltage and current is commonly expressed in complex number form. If there is no phase difference between voltage and current, the imaginary part of the complex number is 0, indicating that voltage and current are in phase. However, if there is a phase difference, the imaginary part is non-zero, indicating that voltage and current are progressing in different phases.